Now we are going to have Cristiano Cunha from Farfetch.
Hello. Hi. So I'm here to talk to you a little bit about a subject that not of you like, but that I love, that is testing. Before that, I just want to introduce myself. My name is Cristiano Cunha. I'm actually the automation team manager in Farfetch. I started as a developer, but quickly fell in love with testing, and I still have the development bug in me, so test automation was the perfect fit. And I'm now work in the automation for about 7 years. On the personal side of things, I'm all about sports and customs, as you can see. But before talking directly of what were our path, our changes that we do, I want to give you a little bit of context for you to understand what was Farfetch a few years ago and understand why did we give the steps that we give and the choices that we have made. So Farfetch was almost since the beginning an agile company. So it has all the ceremonies, the teams were organized as agile teams. It has all the functions within one team. We had a brand strategy in place. It serves us for a lot of years. But as you can see, we had a lot of issues when we grow with merges. Basically, because as you can see, we only launch releases from the main branch, but we had the dev branch and not branch, and features over the dev branch. So the merge fast starts when you merge features to dev, dev to main, and when you multiply this for, I don't know, 50, 20, 30 teams, it's real hell. And I'm with Mauro in this. We had war rooms and 2 or 3 people doing merges, and after that, the real work comes when we go into test this. Because the first time we have everything integrated is when it reaches release, the main branch, and after all the merges, we have like 3 days to put that thing to work because a lot of things have changed. So this is a pain, or was a pain. We have the eternal fight between manual and automation tests. Of course, manual was winning because we didn't invest since the beginning in automation, and we hire a lot of manual testers. They are great at their job, they know a lot about the business, but if we want to continue to grow and be faster of the things we do, we need to invest in automation. And of course, not having automation, everything we put in production was a big pain in the ass, and it was a very difficult job to do. And this will not serve our purpose for the future. So this is where we were, and Farfetch grown, and it's still growing. And when we had to the mix a lot more people, and we want to keep producing and giving our users new features, and we have more and more people producing things, it starts to be a little bit difficult to be fast and to be agile. So we wanted to have every time faster deliveries. We wanted to be fast to deliver our products. We wanted to be fast to give value to our users. We wanted to be fast to deliver new things because of our competitors also. We wanted to have a monotonous release process. We don't want to have a very big effort in the end to deploy things, to check if things are okay or not. We don't have manual intervention on those deploys. We don't want to have surprises at the end, basically. And we want, at the same time, increase the confidence of the delivery. Because we want to deliver faster, but we want to do it very, very safely, or most safely as possible. So it kind of strikes us. We want to continuously deliver our things and continue delivering them at, with the quality that we want. So basically, we look at what were the big players doing, and we saw that we were already at a stage that it's not the beginning of that, but we had some path to cover, and we decided to go to continuous delivery. And the steps that we want to take to reach continuous delivery are the ones that I'm going to describe to you, more focused on the test bit of it. But we knew for sure that continuous delivery is not the way we wanted to end. We wanted to reach what we call the DevOps nirvana. But to do that, and regarding tests, we have a lot of challenges ahead. And to be clear, we needed to share our goal with all the company, with all the persons that are involved in the process, because it's not a change that only one or another team can do. It's something that all the company must be invested in. So we want continuous delivery, and continuous delivery is not something easy to achieve, but it's really something that we wanted to reach. So what is this? This is nothing more than building software, like our friend Martin Fowler says, in such a way that it can be released to production at any time. We just had a little sentence from his friend, Jess Humble, that talks about add to that sentence with safely and quickly in a sustainable way. This is a very important part for us because we want to deliver our things very fast, very quickly, but keep the quality and be able to sustain our growth with this process in place. So, what major changes are needed? I think like 2 or 3. No, it's a hell of a change that we need to do. This is my best slide, as you can see. Very few images and a lot of text. Didn't have time to break this into small images. But going quickly through those points, because I'm just going to focus on the last one, more directly related to tests. But we have challenges on changing the way we had things in source control. We have to change the things, the branch strategy that we have. And we start slowly, but the target is aggressive. We want to have everything in source control. And we have everything committed to main. As you can imagine, this is not something easy to achieve, especially the second one, because of the type of applications that we have, the legacy code that we have, the monolithic applications that we had at the time. So we start at least with the new things, so the new services, the new applications that were starting at the moment will start in the right way. So the new things that are coming on are all committing only to main. The rest of it will depend in a series of factors that will be already have been covered around this. Retrocompatibility starts to be a big thing for us because if we want to deliver in the fastest way, we wanted to be retrocompatible with our version, especially when we don't have only one server in production, we have 30 servers in production, and we don't instantly update them all. So we have a moment in time, even if it's only a few minutes, that we have both versions of our applications working in the same, available for our users. So we need them to be retrocompatible. For a degree, we need them to be independent. And this independence is more looking at the tests. I want to be able to test one specific application without the need of the 30 service that it depends on. We need build generated automatically, deployed automatically, And we have a big challenge regarding environments because our product has a big database. It's a very, very challenging thing to replicate that data in our environments. So, and the stability of the environment. This is something that we are always trying to achieve, and it's still nowadays our struggle with environments. You Linux fans that you have here, we're going to ask. I always get this question. In containers, did you guys use containers? Well, we're starting to now, but to the date, we use mainly the Microsoft stack, so we don't have the possibility to have containers in Windows machines until recently, and it's not that stable for the moment, but we are working on it as we speak. Then we need to invest in test automation, and this is something that developers don't like very much, because, you know, it's something that can break the code. It's probably extra work, but to have continuous delivery and a pipeline, we need automation within the deploy and within the automation tests. More than that, we need the persons to be able to understand what is wrong when it breaks, and not trying to search for the Holy Grail every time the pipeline is read. So we need an easy way to understand what is wrong. We need logs, we need images, we need whatever, to the teams being able to understand exactly what is wrong when the pipeline is read. And the big challenge of all, it's the main mindset that must change, not only for the testers, and you will see why, specifically for the testers, but for all the team. If you want to start walking towards the DevOps way of doing things, everyone needs to start changing the way they are working. They need to worry about different things that did not worry them until now. And this mentality change is particularly challenging because it's not something that I say, let's take your team, you're going to take a course of 1 week and you're going to be good regarding your mindset. You're going to be clear and fresh. It doesn't work like that because we are humans and we tend to be accustomed to the daily things, the things we're used to do, and the change is always something that we are not used to and don't like to a lot. So how did we tackle this challenge of automated tests, and how do we invest in automation within a company that is always growing, that has a lot of teams, and that we have testers that are mainly manual testers, some with technical skills, not much, and start having all these persons investing in automation. So what we did, we create a series of core teams, teams that do not work in Agile, in the Agile methodologies. They are only there to produce services for the other teams in order to ease their work regarding security, performance, and automation. My team is the automation bit of it. By the way, we did not do test automation. We don't produce tests. We produce frameworks and tools and services for the other teams to use to ease the test automation bits. So the tests are written by the teams, by the developers of the teams. If the tester has the technical capability, it will help. If not, it's the responsibility of the team to have the tests developed and implemented for their pipeline. And to do that, we started looking at what we had in terms of tests at the moment, and we committed the same errors that the others did when they start investing in automation. When we have a lot of manual tests, mainly with web applications, what we tend to do is automate that, and it's a direct mapping between what it was done manually to what it was done automatically. So instead of having this very neat pyramid, we start to have more an hourglass shape of tests. So we have unit tests, and the UI has exploded. And this started to be difficult to maintain. The tests took long to run. And so we get back to this pyramid, and we start to define a strategy to cut down times in tests and bring down the maintainability and the rapidity, the way the tests run in the fastest way possible. And we come to see in our cycles that when we have a lot of pain in a certain task, like the merges, like the regression, the manual regressions, we see a lot of persons in pain. So they are suffering with those tasks. And we wanted to invert that. So we wanted to show to the people that if it hurts, we need to do it more often and not letting that go until the end, and we have a big pain every time it goes. And we want to do it more often, not because we like this, but it's because we know that if we cut down that big pain in smaller chunks, it's more manageable to have, and if we do it more and more often, it starts to disappear and not being a pain anymore. So for the tests, we tackle that on, and we are moving with this way of doing things. So we're shifting left. We're trying to invest more on the tests in the base of the pyramid, so in the left of the pipeline, more closest to the build, and this will help us to detect early the bugs in the build, have tests that are more faster to run, and more sustainable for the teams to maintain. But of course, for that, we needed to define a way of doing things differently than what we are doing until now. So we define a series of stages of tests that will match pretty much with the stages of the pipeline. And we have decomposed this in a way that we can have what we have before. Let me give you an example. Like if you have a login in a web application, what a manual test will do is basically try every variation on the login within the web application. So I go to web application, I put a correct login, I fail with an invalid email, I put an invalid password, I try that login in different pages, all manually. And what we want to do is cut down on those tests, so I don't want to have all those tests on the UI, on the last stage, and cut them down in smaller bits of tests on different types of tests that when we have the results of all of the runs, we will have the confidence that it will not break. Although we can miss some things, but we need to invest in the critical areas of the testing. So unit tests are guaranteed by the developers, and we added to that with component tests. We think that unit tests are great, but we can add to them and save some time if we wanted to start validating like interfaces or a junction of different unit tests. Instead of having only the unit tests checked, we can have a component validation or an inter-component validation. This is something that does not need the application, the service to be running, so it saves us time. These are tests that are really, really fast to run, and they cover a lot more than only unit tests. And this is the first stage that we wanted to add to our pipelines. The second one is mock tests. What will come about, and when we have one applications that use a lot of services, even if they're our own services, if we start testing that application, what we are doing is not only test that application, but we are testing the services also. So the scope of the tests is really not only the application, but everything. And when one service is down, what happens is our test will fail, but the application is okay, because what failed was the service and not the application. So with this level of tests, what we want to do is introduce a mock server for us to be able to focus our tests in our application without the dependency of the services. This allows us to do other things than not only tests. First of all, we can control everything in our test scenario. So if we control what service 1 and service 2 is returning, I can choose to return a list with 10 elements, a list with 20 elements that will give 2 pages. I can return a 4-4. I can return timeout, everything that I want, because I control everything that is underneath. And it helps because with the combination of component tests and mock tests, for example, for the example that I gave, the login, I can test that login here, and I can do the maximum of the combinations that I have, like the invalid login with the invalid password, invalid email, with mock server, and validate that the application behaves okay with the different situation that I have. And as this is really, really faster and really easier to maintain than the tests of the UI, it will cover a lot of ground here. Afterwards, we have what we call system tests. And this is the last stage, not the last, but the last that we have fully automated tests, where we're going to launch tests from a different machine. We always launch tests from different machines where the service is installed. It's a good practice. And what we do is we have a target machine where we have all our infrastructure of the application and everything that we need. And in here, what it's supposed to do, it's running only the workflows of the critical workflows of that feature, of that application that we have here, and reduce those tests in the other stages. And in here, what we really want to test is successful login. And that's enough for us, because the rest is validated before. And then, because we have great manual testers, and they know a lot of the business, and they are the ones that know the combination of buttons and links that will crash the application for sure, we wanted them to apply that knowledge in the pipeline, and we wanted to give them an environment where they can do that in the best of the ways. So we have an acceptance test environment where we run smoke tests, just a set of critical tests to assure that they can test our application without clicking in a link and that blows in our faces. And they do the exploratory testing. So looking at this in a pipeline way is we're going to have different stages where we're going to have the implementation of those tests, the execution of those tests, and we're going to have successfully status of what went wrong. And we want to have this every commit, or depending on the team, every X time that the pipeline runs. And incrementally, we can see what is happening, and if that check-in breaks or not to build. And if it breaks, we can understand it easier, because if it has broke on the mock tests, I'm pretty sure that the problem is my application. If it has broke in the later stages, I'm pretty sure that the problem are the other services, because my application is assured on the previous stages. And if it doesn't build, I'm pretty sure that is a commit that is wrong. And it helps me to pinpoint the problem of the pipeline. With the pipelines, we have also the green pipeline mentality that we have to defend and go and speak with every team every person in the team, because we wanted the team to care about the pipelines. We want them to look at them and have that mentality that if it's broke, I'm going to drop everything that I'm doing and I'm going to turn it green, because a lot of other persons are depending on my work. And of course, the mindset is really important, and we need to be able to give the persons the possibility to change their mindset in a safe environment. So we don't, in a fail-safe environment, so we don't want to judge them and criticize them if they fail. We want them to fail, to learn, and to change things around. I'm going to speed up because that thing is red. It may blow. I don't know if you tell me it's blowing, no. So the last bit, I'm really ending, it's I need to give the persons the ability to understand what went wrong, and we invest a lot in reports, in knowing exactly what went wrong. We have the description of each step with times, with stack traces, with logging, with images, with everything that we can add to have the detail of what is wrong. We had also coverage reports to understand if I'm going the right way or not in terms of testing, and a lot of other stuff that we can talk afterwards. And an important part of continuous delivery is visibility. If the teams cannot see what is happening, if my pipeline is red, it doesn't serve our purposes. So we built a series of dashboards, and we have teams with televisions where they can see the status of those dashboards, where they can see if they broke the pipeline or not, and they can act really fast upon it. So the last bit of it is everything is great when you start investing in these things and we start evolving. Oh, shit, it's blinking. But we need to follow the evolution. So we need to understand if the teams are producing automated tests or not, and if they are producing the automated tests in the right way to help the teams to understand if they are producing or not. If they're not, we go there and we try to help them to produce more automated tests. This is just a sum up of some of the tools that we use. We have a bunch more of that is there because we're always evolving and changing. And that's it. So I just finished before the blow-up.
We are fast learners, so if it hurts, do it more often. Questions?
Hello. Good presentation, by the way. And my question is, how can I say this? How do you test the response of the services of your mocks? For instance, the API of the service can change, and how do you synchronize your response, basically?
That is still something we are investing in because we can have a gap between the new version of the services and the mocks that are being used. But what we are trying to do is account responsible the services to produce the mocks. So if a new service will produce a new version of the service, it will produce the mocks. And we're still working on where to publish them for the other teams to know about it and start to updating that. But we are, at the moment, we know that we can have some discrepancy between the versions, but we hope to find it in the next stage. But we are working in having that workaround while we are investing in having the publication of the mocks in the service in the central way in order to be consumed by other services. We don't have that yet, but we are working on it.
Thank you.
My system says there is no question. Or there. I should test this more often.
Hello. In your case of system testing, how do you handle your database data? It's like real data or some data features or similar?
Actually, we have two ways of doing that. We are updating our service with weekly data from live. So the service that we are using in continuous delivery pipelines are updated with live data every week. So we have 1 week of delay from the last data. And we have the possibilities to inject data in the database when running the tests. So it's a trade-off, and it's really a decision of the teams of what are the strategy that they're going to use to inject or use the data that is there.
Okay, another question. This is not really related to tests and automation, it's more about Git workflow. Since you are doing commits directly to the main line, how do you handle things like code reviews, for example?
Yeah, actually we are doing that, but it's a merge request that is done, and the code reviews is upon the merge request, and afterwards we have the merge to the main branch. And we don't have it in all teams, like I said, but the one that have that are working like that, typically more smaller teams with newer services, but they manage to have that. But they work upon merge requests. So after merge requests, we have code reviews throughout the team, and after approbation and a run of our pipelines, it will be merged to main.
I think they are afraid of you. Thank you.
Thank you.